This video will demonstrate the performance of a point biserial correlation. And this is typically done in which one of the variables that we're trying to correlate with another variable is a dichotomous or nominal scale variable. So that would be a category such as male and female that has two levels. So the other variable could be ratio or interval scale, and it typically is. And the other variable is going to be, as I mentioned, dichotomous in nature. So we'll actually use the Pearson correlation coefficient to establish this relationship, but it's a unique case of that because one of the variables is nominal scale. So the data we have here is a mixture of numeric data, in this case overall score or grade in a course, in a college course for example. And then we're going to try and correlate several dichotomous variables with this outcome. And one of the common ways this is typically used is if we look at the score on an individual question on an exam or in a course, and we try and correlate it then with the overall grade. The idea is to see if there's discrimination in that question. So if there's a correlation in which we can kind of see a separation between getting a question right or wrong and then getting a high or low score on the exam, that will give us some idea if there's a relationship between scoring well on one question and scoring well in the overall exam. And then we have two examples of that, and then we have another variable here that we want to see if there's a relationship between what time a course is taken, a morning class versus an afternoon class, and then the grade you get on that class or the grade you might get on an exam, to see if there's a relationship between that dichotomous variable, time of day the class is taken, and the overall score. So we can look at several kinds of point biserial correlations in this example. So in order to run the analysis, we're going to go to the Analyze menu, go to Correlate, and then Bivariate, because again we're going to be looking at pairs of variables here. And we can then move all of our variables over into the variables box. And then we want to make sure that Pearson is checked, because again we're using the Pearson correlation to do this, look at this relationship. So we make sure that's checked, and that is the default. Alright, then we click OK. And we can get our output. And then we can look at these individual relationships here. But what you've got to remember here is we're looking at the relationship between a dichotomous outcome and a numeric outcome. So it might be a little confusing at first to kind of get an idea of what the correlation is actually telling us. But if you keep in mind that we're using numbers to code the categories for our dichotomous outcome, then that can sometimes help keep that straight. So let's look at the overall score relationship to question number 1. So as you can see here, we've got a positive correlation between these two variables. Remember, question 1 was coded using 0 and 1. So, and then the overall score was coded using 0 to 100 as possible scores. So what this is telling us then, if you get a score of 1 on question number 1, in other words, if you get that question correct, then you're more likely to have a high overall score. So there's a positive relationship between getting question number 1 correct and having a high overall score on the test or in the class. Now if we look at question number 2 compared to the overall score, now we see a negative correlation. So that's indicating that there's a trend towards, if you had question number 2 correct, then you're more likely to have a low overall score. So that's kind of giving you an idea of the opposite effect, potentially. And then lastly, we can look at the class time. And again, this is categorized as using a 1 or a 2. And then the overall score from 0 to 100. So again, here's an example again of a negative correlation, which is indicating that if you're in time period number 2, which in this case is the afternoon, you tend to have a lower overall score on the exam. Okay, and so we can see the first correlation between question number 1 and overall has a very strong correlation, and it is definitely statistically significant at the 0.05 and the 0.01 level, whereas the correlation between question 2 and the overall score is not statistically significant at the 0.05 level. and the correlation between class time and overall score is trending towards significance at the 0.05 level, but it has not reached that. Now again, in order to visualize this, if my explanation of this doesn't really make a lot of sense to you yet, we can visualize this using graphs, and that tends to help quite a bit when we're doing these point by serial correlations. So let's go ahead and do that. So we're going to go ahead and do a scatter plot so we can actually visualize the relationship between these dichotomous outcomes and that numeric outcome. So let's put in as the Rx variable, let's do question number 1. That was the one that was statistically significant. And then the Y variable will be the overall score. So we're saying that there's somewhat of a predictive ability of question 1. If I got question 1 right, then that will predict or explain what my overall score might be. Let me go ahead and click OK. Okay, and so what we can start to see then is if you had question number 1 correct, which is what the 1 represents here on the X variable, then you tended to have a higher score, overall score. If you had a 0 on question number 1, in other words, you got the question wrong, you tended to have a lower overall score. And again, we can create a trend line on this graph to exemplify that. And again, here's that positive trend line that we see. So if you had question number 1 correct, you are more likely to have a high score. If you got it wrong, you were more likely to have an overall lower score. So this would be a good example of a question that's a good discriminator. In other words, if you can get question number 1 correct, then that means you're probably going to get most of the other questions on the exam correct. Now let's look at one of the negative correlations. So let's go ahead and create a graph for one of the negative point biserial correlations that we saw. And that was the class time. So why don't we look at that one? So let's move class time to the x-axis. Again, thinking that the time of day the class takes place will explain to a certain extent what your overall test or grade class score might be. Okay, so let's click OK. And now here, again, we see this negative correlation. So if you had an afternoon class, there's a slight trend for you to have a lower score on the test. If you were at a morning class, there's a slight trend for you to have a higher overall score. So again, we can create a trend line there to show that. Again, you can see a kind of a shallow downward trend here. So here's an example of a dichotomous outcome and its relationship to a quantitative outcome, showing a negative linear relationship. Okay, to summarize, a point biserial correlation can be used in which we want to develop relationships among variables in which one of the variables is a dichotomous outcome with 2 levels. In other words, male, female, correct, incorrect on a particular question, or some other group membership. And so we can use that then to develop a relationship between that dichotomous outcome and a quantitative outcome.